How's it going, everybody? So today what we're going to be doing is solving absolute value inequalities, okay? You'll notice the steps to solving an absolute value inequality is right there up on the top of the screen. It's 1 through 4. We've got first step, isolate the absolute value bars. Step 2, we're going to separate it into two inequalities, okay? And we also got to remember that negatives will switch the inequality signs. And then step 3, we're going to solve both inequalities showing all the steps, but now we're going to graph your solution on the number line. Now in those steps, they may sound very familiar to you, and the truth is they should. We've been doing this for the past now 2 days, okay, where we've taken the absolute value, split it down the middle, and solve for x. The only difference is now we have inequalities in the mix, okay? But you're going to see a lot of similarities in today's lesson, okay? So let's take a look at this first one. So the first thing that we need to go ahead and do is see if the absolute value is isolated, and indeed it is. So we can go ahead and split it down the middle, and we have 3x minus 7 is greater than or equal to 5. Now, of course, we have to do it on the other side, so we have 3x minus 7 is less than or equal to negative 5. And the reason we had to flip the sign is because we made that 5 negative. Now we just go ahead and solve. So we have add 7 to the other side, so I've got 3x is still going to be greater than or equal to, and that's going to be 12. Now, when we divide by 3 on both sides, we get x is going to be greater than or equal to 4. Okay. Now, on the right-hand side, we'll do the same exact thing. We're going to add 7 to the other side, and we have 3x is less than or equal to, oh, not 5. It'll be less than or equal to 2. Then we will divide by 3, and we have x is going to be less than or equal to 2/3, okay? Now, these right here are what we're going to put on the number line, okay? So let's go ahead and take a look at the number line. And we're not going to be too critical over the number line itself. We'll just go ahead and put 2/3 right here. And we'll put 4, let's just say right here, okay? We won't be too critical about it. Now, you'll notice when I put them onto the graph, you'll notice I put them as closed circles. The reason is because we have to abide by the greater than or equal to for the 4 and the less than or equal to for the 2/3. Remember, they have to be closed circles. Now let's go ahead and talk about which direction they're going to follow on the line. Well, for this one right here, okay, I said that he was going to be greater than or equal to. So all the numbers greater than 4 are going to be things like 5, 6, 7. Those are numbers going this way. Okay, so we would shade that way. For this one, we notice that its x is going to be less than or equal to 2/3. So numbers that are less than 2/3 are things like 0, -1, -2. Things going in this direction, okay? So you'll notice we have our arrows going out, okay? They're going to be going out. And that's how we do our number line. Let's do another example. So for this one right here, we have the absolute value isolated, so we can split it down the middle, okay? And I've got 1/5 m minus 18 is going to be less than 6. And then I've got 1/5 m minus 18 is going to be greater than -6. Because remember, because I made it negative, the sign or the inequality must flip, okay, the other way. So let's go ahead and solve for m. So I add 18 to the other side, and I've got 1/5 m is going to be greater than, now 6 plus 18, that's going to be 24, okay? And in order to get rid of the 1/5, I got to multiply by the reciprocal, which is 5/1. And these will divide to 1, and I've got m is going to be less than, now 24 times 5, I believe that's 120 if I'm not mistaken. 120, okay? Now, let's look at the right-hand side, okay, because this is a possible answer. So I add 18 to the other side, and I've got 1/5 m is going to be greater than 12. Now I'm going to multiply by 5/1. And that's going to be m is greater than, I believe, 5 times 12 is going to be 60. Okay, so that's another possibility. Okay, so let's put that on the number line. Now, of course, we're not going to be overly critical of where these are going to be. And so we've got 60. Let's just put them right here. And let's put 120. Let's put them right here. Now, you'll notice I put them as open circles because with that inequality, you've got to make sure that they're not closed, right? Because we're not including them. It's not equal. But let's go ahead and see which way we're shading him. So this one right here in red, we are making him go to the less than. So we need numbers less than 120. Well, numbers less than 120 are things like 100, 90, 80. They're going in this direction, okay? Now, for the m is greater than 60, okay? That's going to be things such as 70, 80, and so it's going in this direction. So what we see here is the graph itself exists between 60 and 120. Now, it doesn't fill in the circle, okay? Don't fill in the circle. It just exists in between them, okay? So that's how we would do that graph. Now, let's look at another example. Number 3. Now, this one right here, you'll notice the absolute value is not isolated. So we got to go ahead and isolate it. So we subtract 6. So I have negative 18 minus 2w is less than or greater than. Now, negative 2 minus 6, that's going to be negative 8. Now, we have to divide by a negative 1 to get rid of the negative on the outside. So we divide by negative 1. And because I divide by a negative, the inequality must flip again. And so I'm left with, and what I'll go ahead and do is I'll kind of move my work over here so I don't go into my number line, okay? Oh, there we go. And I've got absolute value of 18 minus 2w is now going to be less than 8. Now he's isolated, and I can go ahead and solve for my w. So I've got 8 minus 2w is going to be less than 8. And then I've got 18 minus 2w is going to be greater than negative 8. Now, once again, I flipped the inequality because I made the 8 negative, okay? Now we solve. So I subtract 18 to the other side. 8 minus 18 is going to be negative 10. Okay. Now I'm going to divide by a negative 2. Now when I divide by a negative 2, that's going to flip the sign again. So I'm going to have w is going to be greater than 5. Okay. So that's one possibility. On the right hand side, we do it again. I subtract 18 and I've got negative 2w is going to be greater than. Now, negative 8 minus 18, that's going to be, what did we say? 26, right? I think that is. Yep, that's going to be negative 26. Now, we're going to go ahead and divide by a negative once again, and so we get w is going to be greater or less than. Now, 26 divided by 2, that's going to be positive 13. Okay, so what we're going to do is we're going to take these numbers and we're going to put them on the number line. Okay, so I've got my 5. We'll go ahead and put him right here. We'll go ahead and put the 13 right here. Now, I should have gone ahead and made sure that those circles are not closed in. Oh, that's not my eraser. That's my eraser. I need to make sure that those circles are going to be, what? Open circles, right? Because it's not equal to. So we got open circle there, open circle there. Now, the W says that we need, our W's are going to be greater than 5. What that means is we're going to be going in this direction, okay? Now, 13 says that we have W is less than, okay? So that means we're going to be going to the left. And once again, the graph exists between them, okay? Alrighty. So those are some examples of what to expect for inequalities, okay? Now let's take a look at some special cases. Now, once again, this has a lot to do with the idea that absolute values, okay, can never be equal or less than negative numbers. So you look at this, case number 4. It says that the absolute value of x, okay, is greater than negative 5. Well, it should, because anything that goes inside of an absolute value should be positive. So that means no matter what it is, it doesn't matter what x you try to put in there. You could put in a negative 100. You could put in a positive 5. You could put in a 3. You could put in a 3 million, negative 3 million. And it's always going to be greater than negative 5 because it turns to positive. So what that means is we have all real numbers, okay? And you can just simply put R, okay? Because that tells me, hey, we have all real numbers. Or you could say X is an element of the all real number system, okay? Stuff like that. Now over here though, conversely, we have this saying that X is less than negative 5. Well, there's no scenario ever that that's going to be true because X is always positive. And the last time I checked, positive numbers are greater than negative numbers, okay? So this right here is never going to be true. So we have a no solution, okay? Now, over here, the reason why this is a special case is not necessarily because it's going to be all real numbers or no solution, but because it looks a little bit more unique on the number line itself. Let's go ahead and solve this one. It shows here that the absolute value is isolated, so we can go ahead and break it down the middle. I've got x plus 5 is going to be greater than 0, and I've got x plus 5 is going to be less than my negative 0. Now, that negative right there, is it needed? No. I mean, negative 1 times 0 is still 0, so honestly, we can just have 0 there and it's totally okay. Doesn't change a thing. But it does flip our sign. When we solve for the left-hand side, we get x is going to be greater than negative 5. And on the right-hand side, we get x is going to be less than negative 5. Okay? So, let's take a look at that on the number line. Okay? Now, the first one says that x is going to be greater than negative 5. So that means it's going in this direction, okay? And then it also says that x is going to be less than negative 5. So it's going in this direction. So basically, the reason why this one's a special case is that you can have any possible x value except negative 5, okay? You have everything at your disposal except him, and that's because we didn't include him, okay? And that's because of that inequality. Now let's take a little bit of a shifting gears and let's take a look at some more problems, okay? So let's come up here. Oh, went too high. So this one right here, we're probably going to see those special solutions in action, so let's keep those in mind as we work them, okay? So let's go ahead, isolate isolate the absolute value. So we subtract 5, and we have 1/2. 2x minus 5 is going to be greater than negative 3. Now we're going to multiply by a 2. Okay, so we multiply by a 2 over 1. It's reciprocal. And so we have absolute value of 2x minus 5, okay, is greater than negative 6. Now, we just got done talking about this. Is an absolute value always going to be greater than negative numbers? Yes, it will, and it should, because absolute values make everything positive. So, of course, positive numbers are going to be greater than negative 6. So we have all real numbers, okay? All real numbers. So that was easy. That was nice. So this one right here, let's take a look at this one. We don't have the absolute value isolated, so let's go ahead and do that. So let's subtract 6. So I have negative 2x minus 4 is greater than or equal to 4. I'm going to divide by negative 2. Now, because I divided by negative 2, it's going to flip my sign. So I have less than or equal to negative 2. Now, let's think about this. Is an absolute value less than a negative number? And is an absolute value going to equal a negative number? And there's no way that can happen, because Once again, it goes back to that idea that absolute values are always positive. So this, in fact, is easy. This is a no solution. We don't do anything further. Boom. Now, if you're curious on this one right here, you might be saying, well, Mr. Farmer, how do we indicate that on a number line, for this one? Well, if you had a number line, it's just all of them. So you just kind of like, I don't know, you could do this forever. I don't know if you'd want to do that forever, but you could, I guess. But that's the idea for the number line for something that goes to infinity or something like that. It's every possible x value. Never stops, right? So just an idea there. Alrighty, so now let's take a look at a word problem where we're going to be using absolute values and inequalities. It says here for this problem solving, it says a food manufacturer specifies that every family-sized box of cereal should have a net weight of 25 ounces with a tolerance of 1.2 ounces. Write and solve an absolute value inequality that describes the acceptable net weights for the cereal box in a family-sized box. So honestly, if you remember this phrase, it will definitely help you. So basically, it's going to be variable minus goal is going to be less than or equal to your tolerance. Okay? So with that being said, okay, if you always set it up like that, you're going to be spot on, okay? So let's go ahead and see. The net weight of it is 25 ounces, okay? That's our goal, okay? So we can go ahead and say the variable for this thing is going to be, I guess, since it's food, I guess we can call it F. So we have the absolute value of F, okay, minus our goal of 25 ounces, okay, because that was our goal. That's what we want it to be. It should have that, okay? It may not always, but it should be less than or equal to our tolerance. Now, what this means is something that the company or the organization is willing to be plus or minus, okay? I don't know if you guys have ever dealt with percent error or things like that, but tolerance is kind of like that, where we will tolerate the net weight to be less than or equal to that. We are okay with that. But if it's anything bigger than that, we're not okay. So that's what that tolerance is. And our tolerance, it says in the problem, is 1.2. And that's all there is to it. That's all we do to solve it. Okay? Now, of course, this right here is what we would go ahead and do. We could break this apart and solve for F, right? We could figure out those two different types of what F could be. But that's how we would set up the problem, okay? Set up that tolerance problem. Now, I'll probably do a warm-up with you guys to expand upon this because we only did one of them. But that's the idea, and so let's come in tomorrow ready to look at that, okay? That's it for the video, guys. Thank you so much. Alrighty, bye.